Assalamu alaikum warahmatullahi wabarakatuh. Today in this video we will present you with the project final state. In this presentation, group project deliverable 4. In this deliverable, we will begin by clarifying all the principles required to complete the project, as well as describing the aggregate concept, encapsulation, array of objects, association including aggregation and composition, inheritance, and polymorphism, before moving on to the last stage, which is testing the game in terms of losing or winning. Are the requirements for our project. As you can see here, we separated each class into two files, definition and declaration. Here, as you can see, we have 6 classes: alien, heart, laser, line, spaceship, and space entity. For example, here, this is the definition file for the alien, and this is the declaration, and here the definition, and this is the declaration file. Here's the definition for the laser, declaration, and here for the line, definition and declaration file. Here's the spaceship and declaration. Here's the definition, and finally this is the declaration file for the space entities.
Okay, I'm Tahia, and I'm going to start by talking about encapsulation. So encapsulation, the attributes are private and the methods are public. So we're going to start by going through all the HPP files. Over here, the attributes are private. The methods are all public here. For the heart.hpp file, the attributes are private, methods are public. Laser.hpp, attributes are private, methods are public, besides draw helper, because since it's a helper method, it has to be protected, so it's put under private. In line.hpp, there are no attributes here since it's inherited from the space entity class. So let's go there. As you can see, the attributes are protected. It's protected from the child entity, which is the line class. And the methods here are public. So we can see that encapsulation is implemented here. We'll go to spaceship.hpp. These attributes are private, methods are public. Besides draw helper, since it's a helper method. So now we're gonna go to the main file to talk about the array of objects. So we have used 2 arrays here, which is for the alien, this is for the heart. And these objects in the arrays, they will be consumed later by array of pointers because you're going to be using polymorphism. The line and the spaceship, here this is the line, this is the spaceship. They are going to be consumed by array of pointers, which is going to be from the space entity right here. So now now that we're done with this, I'm going to mention the composition and aggregation. So let's start by going to the spaceship.hpp file. You can see that the laser bullet here is, it belongs to the spaceship. And because we're using composition here, the bullets objects, it belongs to the spaceship class. And there's no pointer here, so that's where you can tell that it's a composition. So now I'm going to talk about the aggregation part. Let's start by going to the laser.hpp. So over here we can see that the spaceship, alien, and heart, these 3 are associated to the laser class through association. You can tell because over here we're using pointers and all 3 of them. So that's how we know it's associated to aggregation. And let's go to heart.hpp. You can see here that the spaceship is associated to the heart through aggregation. Same goes to the alien.hpp. Here the spaceship is associated with the alien through aggregation. So now we're going to see where we use this aggregation. Let's go to the laser.cpp. So you can see here that the alien object is used in the laser. Since there's a pointer, it's an aggregation. So we use aggregation here because this is to check if the laser collides with the alien. And the same thing goes for the heart. Over here, the heart is sent passed as a pointer, so it's an aggregation. And this is to check if the laser collides with the heart. So that's for me.
Hello, my name is Muhammad Abu Talha, and I will be showing about the inheritance and the polymorphism that I implemented in the project. So first, I created a class called space entity, and this class will be the parent class to all the other classes, and this class will have attributes and this class will have attributes and methods that will be used by many other classes. For example, in the protected, I have put the x, y, width, and height. These attributes will be used by other classes as well. This class also has a constructor which will be used later. These are the virtual methods: draw, undraw, and move. And these are virtual because these methods work differently in different classes. This is the polymorphism part. Basically, draw, undraw, and move are written differently in different classes. That's why they are virtual methods, because we are binding these methods dynamically. These methods are all the same for all the other classes. That's why we are writing the code here in this file, in the space entities dot cpp file. We can see the constructor and we can see all the getters, and since all the getters are the same for all the classes, we are writing it here so that these methods are inherited by all the other classes if they need it. So here in the alien.hpp, we can see that the alien inherits from the space entity class, and so all the methods and the attributes of the space entity class will be used in the alien class. Same thing happens with heart.hpp. Heart inherits all the methods and attributes of space entity. Same thing happens with laser. Laser inherits all the attributes and the methods of space entity. Line inherits all the methods of space entity. And spaceship inherits all the methods of space entity. Now we can see that the draw, undraw, these methods are written differently. For example, draw in spaceship is written like this, and draw in alien is written like this. But since the header is the same, we are binding them dynamically. So this part is polymorphism, and since we are binding them dynamically, we can use them, and these methods are called virtual methods. Also, in the main, I did this part of the code. So basically, if one red square passes the line, ship life decreases by 1. So if one red square, which means one alien, crosses the line, then and if the alien is alive, which means if the alien isn't shot, then it will decrease the ship life. But if one heart crosses the line and the heart is alive and the ship life is less than 3, then the ship life will be increased by 1. So how this is done? By using aggregation. as we can see that if decreased life happens, then spaceship is called in the alien class, and then the life is subtracted, and this method is available in the spaceship class over here. Same thing happens with the increased ship life. If increased ship life happens, then uh, if increased ship life happens, then here ship life increased by 1, and this spaceship object is in the heart class, and this method is in the spaceship class, and this gets activated, so a ship life is added. Also here in the main we can see that we have used uh, an array of pointers, and these array of pointers takes the these array of pointers take the aliens, then this array of pointers takes the hearts, then this array of pointers takes the line and takes the spaceship. So these array of pointers are called space entities, and there are 17 entities. 12 of them are aliens, 3 of them are hearts, 1 of them is the line, and 1 of them is the spaceship. Here we can see by using polymorphism, we are just calling the entities. We are not calling the spaceship or the line anymore. Here we are using the entities pointer to draw the spaceship. Here we are using the entities array of pointer to draw the line. We are also drawing all the objects in one go by using the entities array pointer. We are also drawing the line this way. We can also move all the objects by using the entities pointer. Uh, um, yeah, that is the end of polymorphism and the inheritance.
Hello, I'm Iftekhar Ahmed. My metric number is A20EC3016, and I'm going to explain how the game works. So these red squares are basically the enemies or the aliens, as you can say. We can say these aliens, and these are the hearts, the blue squares, the hearts. So and the big blue square is the spaceship, and this is the line. So these enemies, so the spaceship basically has 3 lives. So if 3 enemies or aliens passes this line, then the player will lose. The player will lose the game is stopped. But if the player gains 1 heart, instead of shooting it, if 1 heart crosses the line, then the player will gain 1 life. So after the player gains 1 life, if 4 aliens instead of 3, 4 aliens crosses the line, then the game will stop. And if there is no enemy or anything, if the whole screen is empty, though no enemy or no heart is left, only the spaceship is left, then the player will win the game. The game will pause. The player will win the game. Okay, now let's play the game. Okay, so yeah, here we can use the arrow keys to move and the space key to shoot. Yes, So basically, right now I'm going to just let go of the aliens pass, and let the player lose. The four aliens will pass, but if 3 passes, then it's fine. If 3 passes, the game will stop. Yes, see. So the 4 passed the line. 4 aliens passed the line. The game stopped. But if 3 passes the line, then the game will stop as well. So let's see how the player wins the game. So this is how the player lost. 3 enemies passed the line and the player lost. 4 enemies passed the line, but if 3 enemies passes the line, then the player will lose as well. Okay, so let's see how it stops. So let's see how the player wins. Sorry. Okay, so this is how the player will win. The player will have to shoot all the aliens. Yes, shoot all the aliens. So all of them. Okay. Okay. I'm gonna kill this heart as well. Okay. 1 passed the line, but that's not a problem because I have 2 more lives. And yeah, I have at least 2 lives. So yeah, this is how the player wins the game. So see, there is nothing left, no heart, no alien. Now the player wins the game. This is how the player wins the game. This is how the player wins the game. Yes. So yeah, okay. So this is how our game works basically, and that is all for that is all from me. Thank you for watching my part.